So we are Team Pookies and we are here to present our project Spiderbot. So myself Rachit Ingvaje.
I am a Theramante. So let's move forward with the problem statement. So home security systems today are overwhelmingly passive. Fixed positioning cameras and motion sensors can only observe a scene from a single viewpoint, creating blind spots in hallways, behind furniture, and across adjacent rooms.
So when an intruder or an unfamiliar person enters a space outside the camera field of view, the system is effectively blind. And by the time a homeowner reviews the notification, the event may already be over.
There is another problem. Elderly or mobility impaired family members living alone may need a system that can actually move, visually verify visitors, remember what happened, and alert the caregiver.
So traditional PIR alarms can produce false alarms, while cloud-dependent cameras add latency, subscription cost, and privacy concerns. Weber addresses this by making the security system mobile, local, and interactive.
This is Weber, a 12 degree of freedom quadruped built around Arduino Uno Q. The goal of this demo is to demonstrate what the robot can actually do and how the Uno Q enables these features. Let's start with the hardware. Weber has 4 legs with 3 degree of freedom each, giving us 12 MG90S servos, which are 180 degree servos, and these are connected through PCA 9685 16 channel PWM servo driver.
On the software side, those 12 joints are controlled by our gate and inverse kinematics code. The physical servo commands are generated from the motion targets and sent to the hardware through the Uno Q.
For sensing, we used the GY87 module, which gives us accelerometer, gyroscope, barometer, temperature sensing, and magnetometer data. We also use the TOF LiDAR sensor for measuring nearby obstacles.
The software continuously uses this sensor information for stabilization, object avoidance, and spatial awareness. So these sensors are not just for displaying numbers, they directly affect how Weber behaves.
For perception, Weber carries a Sony webcam and microphone module, and OLED gives us the visual feedback through expressions.
And the power is provided by 2 lithium-ion cells with a BMS and DC to DC buck converter. Also, for powering the Arduino Uno and the webcam, we are using a power bank. So combining this real-time hardware side with Linux processor capable of running our AI software locally.
So now let's demonstrate one of our major features, quadruped locomotion. Weber can stand, walk forward, turn, and change its gate parameters as well. So yeah, it's in the active mode right now. I'll just place it onto the table.
So coming to the web UI of the Weber, so basically we have a D-pad here for the locomotion. So now it's in stop position. I will put it on forward. As you can see, the robot is moving forward and now backwards. Similarly, it can turn left and turn right. So, there is also auto mode. So there is also auto mode. In the auto mode, the robot will behave autonomously and go through the boundary of the rooms according to the TOF sensor data.
Now these parameters which are visible in the web UI, the body height, step clearance, stride length, step cycle, and obstacle stop distance, all these could be tweaked by human intervention, as well as the AI model itself can intervene in the autonomous locomotion and can also tweak these parameters as per the most optimum locomotion. And now this is the camera feed view of the robot. So for the camera wise AI features, there are particularly 3 peculiar features. One is person detection, person recognition, like face recognition, and the third is object detection and recognition. So basically right now Rachit is an identifiable person for the robot, and I am an intruder, that is unknown person. Like my face isn't been trained for the ML model. So when the robot sees Rachit, in the visual detection logs, it will mention that it had been recognized Rachit, and whenever it sees me, it will say unknown person detected. Okay, and now there is another feature preceding these AI camera features, which is follow mode, right? So whenever the follow mode is on, right? So what happens is when an intruder, let's say, intrudes a place, the fixed camera positions don't give the entire visuals of the let's say motion of the intruder, right? So what we implemented is whenever the spider robot sees an intruder, here in this case it's me, right? And whenever the intruder moves, let's say I'm moving right now here like this, it will arranges, it will move as per the intruder. Like the intruder must be in the center of the frame. Like the robot will track the intruder's movement and try to capture the entirety of its motion in its database.
So another feature is that whenever an intruder is detected, it sends a telegram message. So basically I have received telegram messages regarding along with the screenshot and the confidence scores.
And also the teeny tiny LED, these eyes, this face could be changed, like the expressions on them via this particular interface of the OLED faces. So let's keep it on neutral right now.
So the next feature we have is the LLM chart. So we are using a Qwen 2.5 0.5 billion parameter behind this, which is locally running on the UNO queue. All the events which are recorded in the webcam, basically face recognition or object detection, they are stored in a local SQLite database along with the timeline and the room in which they were occurred. So here I can just ask it basic questions like where was Rachit last seen? Till the LLM answers, let's move forward with the live telemetry.
Right, so as mentioned earlier.
Okay, so the reply has came. It says Rachit was last seen in the living room.
Also, that reply was printed on the OLED screen as well. So now, moving on to the live telemetry part. All the sensor data, all the sensors which has been implanted on this particular robot, these all real-time sensor data is available on the live telemetry part. Like the TOF sensor, real-time data, the temperature from the GY87 module, the let's say acceleration and gyro of GY87 itself, and all. Also in the camera features as well, the object detection part of the three features which I mentioned was this. So the box would be detected here. So what happens is in let's say warehouses or godowns, the equipments or the content of that particular warehouse has been detected by the robot, and it can also mention that where that particular equipment was present. Like if the query was given like where was the box earlier seen. What it's basically doing right now is fetching the like last seen data from its SQLite database and then like showing the results here.
So till the LLM generates a response, let me explain you the occupancy map. So basically, as the robot moves around the room, it will map the layout of the room according to the TUF sensor data. And then you can actually add room box. So basically, if I click add room box and select the room, I can name it. And whenever in the future event occurs in this room, this room name will be stored in the database. So it can be queried later. So if I will just put living room and okay. So now from the future, in the future, if any events occurs in this box, then it will be stored.
The box was last seen in the living room.
So as you can see right now, the reply is also been shown on the OLED, and the AI had already like identified the last position of the box and like showed here flawlessly.
So the final and one crucial feature of our WebR is that autonomous tasks. So the LLM can delegate some tasks to the servos and control the servos independently. So I will just tell it to go forward.
Let me just position it in the back.
So as you can see, the robot moved on its own. I will click stop now.
Yeah. So by itself on the output of the LLM, the robot was moved.
Similarly, you can tell it tasks to run in circles, run in a single room, or any other task which can be performed by the LLM.
Yeah, so the core idea behind WebR is simple. Instead of another passive security camera, we are just giving the camera legs.
So it combines a 12 DOF quadruped, real-time hardware, on-device computer vision, local AI, persistent memory, spatial awareness, and real-time alerts into a single security platform.
And this is what we wanted to demonstrate with the Arduino Uno Q, how one compact platform can connect physical robotics with on-device intelligence.
That was all from our side. Thank you for watching.
Thank you.